Okay, in this review lesson, we're going to talk about raising a power to a power. So to start off, we're going to review just a little bit from what we did last lesson, but we're going to identify the value for the variable. In this case, what is the value of x in this simplified expression? We're going to remember that 7 times negative 9 times 7 times negative 3 is 1 over 7 to the 9th times 1 over 7 to the 3rd. And when we're multiplying, we add, which is 1 over 7 to the 12th. But because the x is up here, we can rewrite that as 7 to the negative 12, which is the same thing as saying 7 to the negative 9 plus negative 3 equals 7 to the negative 12. So x in this case would be negative 12. When we're dividing them, we subtract, whereas when we're multiplying we add, dividing we subtract. So we can rewrite this as 11 to the negative 4th minus a negative 8. And negative 4 minus a negative 8, we add the opposite, that is equal to 11 to the positive 4. So this would be y equals 4. So that's just a review of what we did. So now we're going to use what we know about that to work on raising a power to a power. So if we look at this, 5 to the 4th, all of that to the 4th power, we're going to expand it. So that's 5 to the 4th times 5 to the 4th times 5 to the 4th times 5 to the 4th. The product of powers rule says we can add all those exponents with the same base. So that's 5 to the 4 plus 4 plus 4 plus 4. And that is equal to 5 to the, x is going to be equal to 16. So that's 5 to the 16th power. Well, what can we know from that? Well, 16 is equal to 4 times 4. Remember, multiplication is just fast addition. So 4 plus 4 plus 4 plus 4 is 4 times 4. So in that case, the power, raising a power to a power, when we're raising a power to a power, the rule is you multiply the exponents. So in this case, 4 to the 6 to the negative 3 is equal to 4 to the 6th times a negative 3, which is equal to 4 to the negative 18th. This case, we have 4 to the negative 3 times negative 3. Negative 3 times 3 is equal to a positive 9. And we could rewrite all of those very simply. We could say 4 to the negative 3 times would be 1 over 4 to the negative 3 times 4 to the negative 3. Anyhow, so that would be, whoa. One of these days I'm going to not do that. So before 1 over 4 to the negative 9, and then when the negative's in the denominator, then to make it positive, we put it in the numerator. So that's how it works. So negative 4 to the 9th, all to the 2nd power, is negative 4 to the 9 times 2, which is equal to 4 to the 18th power. And if we have negative 4 to the 0, times a negative 9, well, 0 times 9 is 0, so that's negative 4 to the 0. And anything to the 0 power is 1. Which applies the power of a power rule properly. So we want to look at the power of a power rule. Remember, these are the ones, if we're applying a power of a power, we're going to be multiplying the exponents. Let's just look, see which one. This says negative 7 to, we're going to add them. That's not correct. That would be as if they were being multiplied by each other. Here we're going to add again, negative 8 plus negative 4. Oh, and then they get different answers here. This is negative 8 times negative 4 is negative 32. Well, negative times negative is a positive, so that's not correct. Here we have a negative 8 times negative 4, which gives us 7 to the positive 32. Even though this is written as a positive here, it's underneath in the denominator 1 over, so make sure you are careful about the signs. Negative times a negative is equal to a positive. So if you have a negative power to a negative power, you're going to have a positive. Here's that one. Which power raised to a power is equal to 8 to the 12th? So let's look at all of these and find out which ones. Well, this is 8 to the negative 3 times the negative 4. Negative 3 times negative 4 is a positive 12, so that one is. 8 to the negative 2 times a positive 6. Negative times a positive is a negative, so that one is not. 8 to the 0 times 12, well, 0 times 12 is 0, so that one is not. 8 to the 1 times 12 is equal to 8 to the 12th. That one is. 8 to the 4, 8 to the 4th, all to the 8th power. We don't add those, we multiply them. 8 to the 4th times 8 equals 8 to the 32nd. That is not. And 8 to the 6th, all to the 2nd power, is 8 to the 6th times 2 is equal to 8 to the 12th. So that one is as well. Which one is equivalent to h to the 5th, all to the 2nd power? Again, we're going to multiply, so that's the same thing as h to the 5th squared is equal to h to the 5 times 2, which is h to the 10th. So this one right there. Identify the value of the variable. So if we have 4k to the 7th, all of that to the 3rd, we want to find 4 to the n times k to the 7th to the 3rd equals 64. Now when you have two terms inside, remember you've got to take this 3rd power to each one. So 4 to the nth is the same as 4 to the 3rd. So n in this case is equal to 3, and then k to the 7th, all to the 3rd is k to the 21, and then they've simplified it, 4 to the 3rd is equal to 64. So that's why this n value is to the 3rd. What's the value of this simplified expression? So here we've got negative 3r to the negative 4th, all of that taken to the negative 4th power. So we take negative 3 to the negative 4, we take r to the negative 4, all to the negative 4, and so we would rewrite this. Negative 3 to the negative 4 is 1 over 81. That's where this came from. And then we have r to the negative 4 times a negative 4, which is equal to a positive 16. So r is going to be r to the 16th. That's all the examples we have there. Just keep in mind that the power to a power rule, you're going to multiply the exponents and keep track of those positive